Good morning, my lovely nines. Right, buddies, this is the big day. This is the day that I get to teach you a brand new unit of maths. One that you've never, ever seen before, and probably, maybe you'll have heard the words of, maybe you've heard the word trigonometry, but you've definitely probably never seen it before unless you've got a bigger brother or a bigger sister that maybe has worked on it and you've happened to see them working on it. But for most of you, this is going to be a brand new topic. So in your book, please put the title, Introducing Trigonometry. And the only things I need for you to have with you today are a ruler, a protractor, and a calculator, okay? So you'll need all three of those things, ruler, protractor, calculator. And if you don't have them yet, push pause and go get them. Okay, and you're back, my buddies. So, here we go, my lovelies. Trigonometry is a super important, critically important, super amazing part of maths, my buddies. It's right up there, like with add and subtract and how important it is for mathematicians. And with algebra, remember when you learned algebra for the first time when you got to year 7 or maybe a little bit in year 6? It's like that. We're doing a brand new field of maths today, and it's super important, really great. Now, yeah, it's so good. Okay, now here we go. I'm going to make you discover it rather than me actually telling you what it is to start with. I've got an idea and I'm going to make you discover it. So here's what I'm going to get you to do to start with. I want you to just sketch me out a little right angle triangle like this. You don't even have to use your ruler or anything. Just sketch me out a little right angle triangle like this. Put the little right angle thing in the corner. But for our angle, you know how normally you call angles like A and B and stuff? Well, actually, mathematicians don't usually use English letters to describe angles. They use Greek letters. And the Greek letter that's used more often than any of the other ones is actually called the Greek letter theta. Okay, so that's how we say it as well. That's me saying it with an English accent. It is theta, my lovelies. You should say it right now. Say theta, theta, theta. So that's the Greek letter theta. Okay, if I say theta, that's my accent, not how you actually say it. That's theta for you guys, okay, guys? So yeah, this is the Greek letter theta, and we use it for angles in the same way that we use like x for variables. It's just the most commonly used letter in the Greek alphabet. It's actually in the Greek alphabet too. Like if you were to look at a map of Greece right now on the Google Maps, you see lots of words that have the theta in it. Cool. Now we have to be really good at labeling triangles. So first things first is I'm going to just make you really pro at it. Hopefully you got this one drawn by now. Here's what you can always do. See theta? That's the angle that we're always on about, okay? Wherever you draw theta is the important angle. Now, what you can do is if you drew a line out from theta and it were to go and hit the opposite wall, well, they actually call that the opposite side, I guess, which makes sense. Yeah, O-P-P-O-S-I-T. Oh, I spelled it wrong, but yeah. O-P-P-O, opposite. There you go. So they call that the opposite side, my buddies. So when you draw a line out theta and it gets to the opposite side, well, it's called the opposite side, and they usually call that capital letter O. Now, you'll see that soon, though. Okay, that's the opposite side. Now, the long side, we have actually talked about this when we did Pythagoras' theorem, but does anyone remember what the long side is called from the Pythagoras' theorem unit? The slanty long side? Oh yeah, that's right, it's the hypotenuse. Hypotenuse. It's the hypotenuse. Now the hypotenuse, you can always tell because it's the one that's on the slant, but you can also doubly tell because if you did that same thing we just did to theta, if you drew a line out from the right angle, it hits the hypotenuse side. Now the other side, it needs a name too, and it's the side that's right beside theta, but it isn't the hypotenuse, but it still touches the theta. In other words, it's adjacent to the theta because it's beside the theta. Well, that's why they call this side the adjacent side. And it's got Greek letter, or English K, or whatever it is, English letter A. Yes, there you go. So that's how you label the triangles, buddies. So opposite, hypotenuse, adjacent. Here's what I'm going to get you to do. Just pause the video right now, sketch them two, okay? So one of them with the right angle at the top, one of them with the right angle on the side, and I just want you to label each side O, A, or H. So you ready? Pause, go. Okie doke, and you're back. Hopefully you did okay at it. The first thing you probably did was drew a line out of the theta to the whatever side it hit, and you'd label that O because that's the opposite side. The next thing you probably did is you said, okay, well the bottom side is the longest, so it's H, but some of you might not have spotted that, and you'd have done the dashed line, like that. Cool. Then you said the leftover side is A, and if you wanted to, you could just say, okay, because it's the leftover side, or you'd have spotted that A is the side that's between the right angle and the theta. Now what about this one? Probably you did the same. Over here then is the opposite side this time. The long side's here. Now I knew that because it was opposite to the right angle, and this side A is the leftover one, or the one that's between the two angles. Happy days, buddy buddies? You're officially triangle labeling legends. Now here's where it gets good. Right, folks. So, what I need you to do is I need you to draw this triangle like ridiculously accurately, okay? Because even a small bit of it being wrong is going to be causing a mega problem for us. So you're going to have to measure super accurately. And can you please draw me this triangle with the bottom exactly 8 centimeters, like 8.0 centimeters. So be right to the nearest millimeter. 8 centimeters along the bottom, then use your protractor and measure exactly 30 degrees up. Okie doke, my buddies, exactly 30 degrees up. Now you might be thinking, oh, he's not giving us the other two sides, but that's actually okay, my buddies. I haven't given you the other two sides yet, but I don't need to, because if you just drew the right angle here with your protractor, you'll be able to draw a line that goes straight up, 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 like that, and then you'll have another line that goes across, 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 like that, up on the angle, and they'll just meet each other with a little extra stick out there and out there. Then you can just rub them out or leave them. It doesn't make any difference at all. So get this thing drawn as quick as possible. Now, I'm just realizing there's a bit of an issue because I can't measure this because my screen isn't in centimeters. So what I have to do is I have to use the maths I'm going to be teaching you in a moment. So yeah, just give me 1 sec. I actually need to know what these answers are. Oh dear. Okay, let's just do it then. So it's 8, 10, 30. Sorry, my buddies. Yeah, I gotta figure out what that is. I would say that when I measured this was pretty much 4.6 centimeters up there. Is that what you guys got too? That was 4.6 centimeters. And then that means that this side, my buddies, is going to be plus 6 squared is, yeah, I'm not using Pythagoras' theorem. I absolutely did this right. And then this was 9.2 centimeters. Is that what you guys got as well when you measured it all? Because I might have just cheated and used maths instead of actually measuring it like I wanted you guys to do, but there's nothing that I could do about it because it's not in person. Cool. So anyway, hopefully you've got this triangle beautifully drawn. Okay, step 1 is just label which side is which. Well, here we go. That's the 30, so coming all the way up from 30 to hit the opposite side is this, the opposite. The hypotenuse is always the long side, that's the 9.2, but also because it is opposite to the right angle, and that leaves the adjacent side here, which is the leftover one, or the one that's between the angle and the right angle. So that's what we got. Now here's what we're going to do. If your triangle is really accurate, you're going to be able to recycle it big time, so this is going to be awesome too. But here's what we're going to do, my buddies. I'm going to make you discover trigonometry all for yourselves. I'm not going to give you any work to do other than this particular slides that we're going through right now, so you just have to show me your good thorough notes from these slides and finishing the parts that I've asked you to finish, and that's going to be it, because it's really important to me that I don't just ever tell you how maths works, but I also make you figure out why it works too, so I'd like you to have a bit of an idea about why stuff works. Cool. So what we're going to do with our triangle here is essentially we're going to chop, 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 chop it down until it's really small. That's all we're going to do. We're going to make a whole bunch of triangles that are similar to the main one, and they're actually called similar triangles, but you don't need to know that yet either. Okay, so step 1 is this, buddies. It's the triangle that you've actually drawn. Now, when you look at the triangle you actually have drawn, in step 1, the opposite side is just 4.6, so we're just going to put 4.6 there. Don't have to worry about the centimeters, just 4.6 is cool. The adjacent side is 8, so that's what goes in there, because the adjacent side was 8, because that's adjacent, because of how we labeled it. And then you need to come up with what O over A is, and that means you do a division. So you go 4.6 divided by 8 in your calculator, 23 over 40, but then you push the SD button, and it makes 0.575. Okay, buddies? Cool, cool, cool. So that's what you've got there. Now, that's all I want you to do. You're going to keep 4, this only was 3 decimal places, but we'll keep 4 of them normally. Okay, you ready? Here's what step 2 is, and we're going to do 6 steps. Step 2 is this. What I'm going to get you to do next is to just take your opposite side and move it in a bit to make a new triangle. Okay, so move it in so that it's there. So now the triangle that we're looking at, so don't erase your triangle or anything, but now when I say the triangle, I mean this one, the one that's smaller because the line moved in a little bit. See what I mean? So we're on about that triangle. So how big is it now? Well, you could move the line anywhere. I moved my line 1 centimeter in, let's pretend. So I'll do this in blue so it looks different. Okay, so that means my bottom on mine is 7 centimeters now, okay? So the bottom on my one is now 7 centimeters, so I moved it in by 1. Which means, unfortunately, I need to cheat again. Which means that I measured this one with my ruler, and I got that actually it was pretty much exactly 4 centimeters this time. And I didn't know how long this side was, but I didn't need to know yet anyway. Actually, I'm going to cut your work down a little bit. I'm going to get this side too, then measure this side too. And how long is this hypotenuse side in the first step? Well, it's going to be 49 plus 16 equals square root equals. But you're measuring it with a ruler. You're not cheating and using maths like me. I think that's pretty much 8.1 now, don't you? Because I might be cheating. But yeah, happy days. So that's like 8.1. Cool? Well, there you go. Let's start filling it in again. So we've just done step 1 now. So we've gone from the big triangle, which was the whole triangle, to this smaller one. Well, in the smaller one, now the opposite side is just 4 centimeters. So like 4.0 centimeters. The adjacent side is 7, which means that when we do O divided by A, 4 divided by 7, we're going to get 0.57 1 4 to 4 decimal places is what we're going to get there. Are you ready? You go now to 6, then 5, then 4, then 3, then 2, or whatever it takes. Okay? One more time of me showing you. We're now done with that triangle. Okay? And what we're going to do now is we're going to come in one more triangle again. So here we go. I'm going to now consider this triangle. We're just making it a bit smaller. So I'm going to get rid of all of these just to show you. Okay? And here we go. Here we go, here we go. Well, now this is 6 centimeters because I just shrunk it by another centimeter. And now we're on about this smaller still triangle. Okay? So that's 6 centimeters. Well, how big is this one? Well, I think it's going to be about, let me just get my ruler out here, about 3.5 maybe? 3.5, is that what you guys got? 3.5 centimeters to get that labeled on as well. It's going to be tricky to label it, but you can find a way. And then the other one is 36 plus 3.5 squared. I'm not just cheating and using Pythagoras' theorem. I would never do that to you, my lovelies. 6.94, so 6.9. And then this time you got this one with 6.9. Cool, so you made your smaller triangle, and you'll have different numbers to me, but they'll be approximately that. Which means that this side, my buddies, the opposite side again is 3.5. This time the adjacent side, though, is 6, and then we're going to go 3.5 divided by 6. Divide by 6, which gives us not 0.5833 is what I got, not 0.5833. Okay, now I'm going to erase everything that I've done, and I'm going to explain to you what you're going to do for step 4 and 5 and 6, and then we're going to do the next step together. Okay, now there goes everything that I've done just there. And right back to the start. Actually, no, I'm going to leave the sticks in, actually. Embedding fonts, what's going on? I think my computer just froze for a sec. That's all that happened. Okay, so here we go, my buddies. Erase, 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 erase. Okay, what you're going to do now for step 4 and 5. For step 4, you're going to move another one in like that. So that's going to be your, step 4. For step 5, you're going to put another one in like that. And for step 6, you're going to do another one in like that, and you're going to repeat the calculation. Now, me completely pretending that I have done it, I'm going to say that for this one I got 0.589 or something. 589. For this one I got 0.574. 574, let's say. 574. For this one I got 0.58 exactly. Okay, so you're going to get that calculation. Now here's what I'm going to show you. Okay, this is the big moment. So you've got all of your things in, and now this is what you're going to do. There's a trig. This is your first ever trig, and here's what you need to do. You need to get your calculator out. So if it's like the old style one like this, like the blue one, or if it's a class whiz, it's the same no matter what. And here's what I'm going to get you to do. See how the first one is 0.575? What you're going to do first of all, what color is going to show up the best? Probably red. Okay. First step then is you're going to push the shift button. So push that first, then let it go. And then the second thing that you're going to do is you're going to push the 10 button, okay? And then it's going to say on your screen, it will end up saying that's 10 minus 1, and there'll be an open bracket also. So that is what will pop up on your screen when you do that. Next step that you're going to do, my buddies, is put in the thing. So it was 0.575, and then you're going to push this button to close the bracket. So push the close bracket button. It'll go like that, and then push equals. So 0.575 equals, and I got 29.9. Okay? I got 29.9 when I did that. Now what you're going to have to do is do that for all of the other ones too. So again, what's the step again? Well, first of all, push the shift button. Second of all, push the 10 button because you want to say 10 minus 1. And then third of all, put your number in. And then finally, close the bracket, push equals. Cool? So you ready? What'd you get for the next one? Let's just check. Shift 10, 0.5714, close bracket equals, I got 29.7. Okay? And you'll finish that for all of them. So shift turn 0.5833, that's the last one I actually measured. 30.3 I got. Okay, and now completely made up. So I'm going to go to a different color because mine's all wrong from here because I haven't measured it. Let's just say this said 29.8. Let's say that this said 31.2. And let's just say that this one said 29.9. Okay, here's the big moment, my buddies. Here's the big moment of questions that you need to answer is this. What do you notice about, first of all, the ratio of O over A? Is it following a pattern or is it not following a pattern, or what do you notice about the ratio as we go down? So a ratio, just because it's division, that's what we call ratios. So as you go down, my buddies, what do you notice about the ratio of O over A? Well, here's what I notice. They kind of stay the same. They stay similar, so you should put that in your book. Okay, they're not like following a pattern of, oh, they're getting bigger or they're getting smaller. They're just staying similar. Now, what happened when you entered it into your calculator using the trig buttons? Well, this is the big moment. Can you see that all of these were very nearly something? 29.9, 29.7, 30.3, 29.8, 31.2, 29.9. Are they near anything? What are they like? What are they near? Look at the picture. What are they producing? Look at this picture. Oh my God, it's producing the angle! So if you know the ratio of the lengths of two of the sides, it can actually tell you one of the angles in the triangle, which is amazing. So what happened when you entered it into the calculator using the trig buttons? It gave the angle at the bottom. Cool, so put that into your books as well. It gave the angle at the bottom. And what comes out when you type 1030? Well, try it. This time don't push the shift button first. Just push 10 only, and then 30, and close the bracket, then equals. It says square root of 3 over 3, but it also says not 0.5774. 0.5774, which what is that? It's nearly the ratio. That is very nearly the ratio. That's like this column that came out. So isn't that cool? Now I'm going to explain to you really quick, so we're going to do this properly soon, but really quick explanation to you. Because of this, what you just discovered, because of this relationship that seems to be going on, that the sides stay in the correct proportion, you're going to unlock an ability to figure out side lengths when you know angles, or to figure out angles when you know side lengths, which is better than Pythagoras' theorem, because you don't have to have all the sides anymore in the same way that you did for Pythagoras' theorem. So it's a bit kind of like Pythagoras' theorem in that it's for right angle triangles and stuff, but it's even better. Now here you go, you ready? See how it was tan that worked with O over A? Well, here's what you just discovered. Your first ever trig formula. So jot it down for me, my buddies, and put a square around it. The formula you just discovered is this. You just discovered that tan of theta is O over A. So in other words, tan of, and theta was the angle, is going to equal opposite over adjacent. Okay, and the reason why you discovered that is, well, we discovered it by undoing the ratio. But remember when you typed in tan 30? Remember when you typed that 30 seconds ago and it made the ratio? Well, that ratio was O over A, wasn't it? That means that tan of theta is O over A. Cool. So that's it. I'm going to explain. So almost you could skip forward if you get what I'm going to ask in a sec. But I'm going to have to explain something really quick. There's two other buttons. Can you see them? Well, there's three other buttons. There's one that says hype, one that says SIN, one that says COS. So the HYP one's a bit different. That's like further math, so you can just ignore it. But the other two, SIN and COS, well, they actually stand for sine, so never ever sin, but they stand for sine, not sin, even though it's spelled sin, sine. And then COS, you say that one as cause in your in English accent. It's cos for me, but it's cause for you. So sine, cos, and tan are the three buttons that are on there. Okay, well, we need to figure out what the other buttons are for. So this is what we're going to do, and this is where I'm going to explain it, and just hopefully you guys will get it, and I'll see wonderful work. We're going to repeat the exact same exercise 2 more times. Now, if you're really neat, you won't have to redraw the triangle, but you can use the previous one that you just drew. Okay? But if you weren't super neat, you should redraw it now. Okie doke? Now, here's what I'm going to get you to see. This is exactly the same triangle, exactly the same steps as the last time, but this time the sides that we're interested in are the opposite and the hypotenuse, okay? So remember in our first one how, oh, I'm just going to steal something, 4.64 and 3.5. Yeah, 4.6 anyway. Remember how this one used to be is 4.6 tall? Well, here's what you're going to do to start with. You're going to this time just fill it in with different numbers. So the opposite side this time is still O, H, and A, but O is 4.6. We're going to put 4.6 there. H was, I can't remember. What was H? Do we know? Did I erase it? 9.2. Nice one. I didn't erase it. H was 9.2. So H was 9.2. So we'll just put 9.2 there. And this time, it's with H instead of with A. So you see what I mean? So it's 4.6, the O, and 9.2, the H. So let's do it. 4.6 divided by 9.2 equals, and your very first one was exactly half, mine anyway, 0.5. But I cheated, don't forget. So yours probably won't be exactly half. And that's cool. What are you going to do next? Well, you're going to do the steps. Go there, shrink it down, maybe cut a centimeter off it, fill in the next line. So then that's filled in, filled in, filled in. Go again, maybe cut another centimeter off, fill in that. Go again, fill in that. Get me, my buddies? And then at the end, you're going to do the exact same thing as you did with tan, but this time with sine. So what you're going to find is you're going to push the shift button, you're going to push the sine button, and it's going to be, and then you're going to put this number in, and it's going to pop an angle out. Now, I'm not going to lie, the angle should still be 30, so it should be something like 30 degrees, okay? It should be nearly there, because we're just trying to show that it works, okay? But what I'm going to look for from you is that you filled in this entire table, all 6 steps, so that you'll know what the answer is supposed to be, okay? So your numbers will look so you know kind of how it works. Your numbers are all going to be a bit like that, okay? They're all going to be kind of near 30 if you're getting it right. Cool. Don't forget to push shift first because you got to get the sine -1 in, okay? When What do you notice about this? What's the same questions? Stays the same. What happens when you put it in the calculator with the trig button? Gives 30. What comes out when you type sine of 30? The ratio, which is 0.5 usually in this case. And here's what you just learned. Second trig ratio. Sine of theta, and it is pronounced sine, not sin. I will correct you if you call it sin, because I can't let you guys call it sin, because if you do, the people who are good at maths will think that you don't know what you're on about, so I won't let you call it that. This is the angle. This is opposite. And this is hypotenuse. Okay, so get that in, TNUSC, get that in, my buddies, for me. Then the final thing I'm going to get you to do, well, I bet you could guess even, I bet you could even guess, is on the same triangle or on a different one. Now we're going to do the same but with adjacent and hypotenuse, okay? I think it was 9.6, so I'm going to draw that back in. So remember how this was 9.6 at the top? Yeah. Okay, that's 9.6 at the top. Well, we're going to go the same again. Adjacent this time. Remember, that's O, that's A, that's H. Adjacent this time is 8, and hypotenuse is 9.6, which gives us 8 divided by 9.6 equals 56, which is 0.8333. 0.8333 to 4 decimal points, and that's what you're going to do. What next? Well, you already know. You're going to go there, like that, fill it in. You're going to go there, again, cut another centimeter off, fill it in. Again, cut a centimeter off, fill it in. This won't take you very long, I promise. There you go, fill it in, 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 fill it in. And after you filled it in, and once you get it all done like that, what are you going to do? Same deal again, but this time with cos, or cos as you guys say, cos in the calculator. So what button do you push again? Shift, first of all. Then you're going to push cos or cos, second of all. Then you're going to put the thing in, like put the number in and see what you get. So in the first one, if I did it, shift cos, see, I can't stop it. I've got a bit of an accent with it. 333, close the bracket, and I got 33.5 on this one actually, so that's not super actually, because you know the answer is supposed to be like 30, so I didn't do very good on that one. 33.6 degrees. Cool beans? Now you should find, by the time you get it all the way done, they're kind of close, okay? They should all be kind of near there. Get that all filled in for me. That's what the homework is. That's what I'm looking for. What do you notice about the ratio of A over H? It stays similar the whole time. What happens when you put it in using the trig buttons? It gave the angle. It gave 30 degrees. What happens when you type in cos of 30? It equals 0.833. It equals the ratio. What have you just learned? That cos of theta is A over H. Now that's it for this lesson. I'll explain to you way better and way more in a way that you'll understand next lesson actually how to use these, actually what we're doing. But for now, I just want you to, my goal for that lesson was just that you understand when I start giving you out formulas on cos and sine and tan that, that I haven't just made them up. They come from measuring triangles, and they come from measuring, from comparing the side lengths of various triangles. They come from ratios of side lengths of triangles, and now you've actually shown that by going through and doing all this exercise for me. So again, all I'm looking for is these filled in tables, a nice picture of all of your work, one for sine, one for cos, one for tan, and then put it onto Satchel 1 for me so I can check that you're getting on all right. And that's it. So that's it from me, buddies. See you next time. Bye, buddies!